In this video, we're going to cover section 9.1, which is matrices and using systems of equations. So a matrix is a rectangular array of real numbers arranged in rows and columns, and we're going to denote the rows with R and the columns with C. And your order is going to be R times C, so however many rows there are times the number of columns. So on this one, there are 3 columns. And 2 rows. So, and then it's row by column, so it's a 2 by 3 matrix. And then, so that's all you need to know how to do for order. Matrices for systems of equations, you're going to take the coefficients and line the variables up, and then you're going to, an augmented matrix also includes after the equal sign. So if we wanted to write this one as an augmented matrix, the coefficient on the first one is 1, and then 2, and then 7. I always draw like a little dash line there so I know that it's different. And then 8, and then 1, and then 2. So that's the augmented matrix for that system. So if we wanted to write the system of equations for this matrix, so this would be x, y, and z. And then over there on the other side of the dotted line is, the dash line is the constants. So I would say 2x plus 3z equals 3. 4x minus 3y plus 7z equals 5. And then 8x minus 9y plus 15z equals 9. So that's how you would do that. And then solving systems of equations using this Gauss-Jordan elimination. So we're going to take our augmented matrix into reduced row echelon form using row operations. And then so you're going to use these row operations to get a new but equivalent solution system of linear equations. So you can flip 2 rows, interchange them, multiply the row by a non-zero constant, and then add a multiple of a row to another row. So we're going to use this here, this little guy here, the same one we made in the first example when we wrote into a augmented matrix. So we're going to just use this. So hang on, I'm just going to zoom in so we can. So 1, 2, 2, 1, 7, 8. And then this will be row 1 and row 2. And then I'll write my steps and I'll explain as I write. So our first step would be to flip row 1 with row 2. So I'm going to put 2, 1, 8, and then 1, 2, 7. So all I did was flip where row 1 and row 2 were. I just flipped the order. And then the second step would be to take row 2 minus a half of row 1, because I want this thing right here to be a 0. I want that to be a 0. And how do I get that to be a 0? Well, I do this. And then I'm going to put it where row 2 is. So I'm going to have 2. So row 1's not going to change. And it'll just change row 2. So that'll become a 0. That'll become 3 halves because half of row 1, which is 1, so, and then 2 minus 1 half is 3 halves. And then I get a 3. So that's the second step. Then our third step, we are going to take, I want this thing to be a 1. So what I'm going to do is I'm going to take 2/3 of row 2 and just multiply it. So then that 3 halves will become a 1. So row 1 still won't change. This still stays a 0. this becomes a 1, and this becomes a 2. And then our fourth step will be we want this to be a 0. So what I'm going to do is take R1 minus R2 and put that in R1. So row 2 won't change, but it'll become 2, 0, and 6. And then our last step will be to get that as a 1. So I'm going to take half of row 1, and then I'm going to put it in row 1. So 1, 0, 0, 1, and then I get 3, 2. So what that means is, since this is first, that's the x, and this is the y, so that means that x equals 3 and y equals 2. So 3, 2 is my solution. And then there's not a whole lot of room here, but that's okay. So if we want to use back substitution, you still write the augmented matrix, and then you use the row operations to write it in row echelon form, not reduced row echelon form. And I'll point that out. I'll point out the difference there when we get there. But, and then you're going to write the system of equations and use back substitution like we did. If you know one of the variables, you can solve for the other ones. So like here, we have x, y, and z. So I know that x minus y plus 2z equals 4. And then y minus z equals 2, and z equals negative 2. So now I can take z equals negative 2 and plug it into that second equation. So I have y minus negative 2 equals 2. So y plus 2 equals 2, so y is 0. Now I have z and y, so I can plug those into the first equation. So x minus 0 plus 2 times negative 2 equals 4. So x minus 4 equals 4, so x equals 8. So then I have 8, 0, negative 2 as a solution. So that's how you do that using back substitution. And then this one says to use back substitution. However, I will show you where you can stop and do back substitution. However, I'm going to do it using reduced row echelon form, just because I think it's a little bit easier. But feel free to stop where you want and do that. So first of all, I need to write this in augmented matrix form. So that's going to be 2, 0, 7, negative 1, 2, negative 5. And I'm just going down. I'm just looking at my x, y's, and z's this time instead of going across. It doesn't matter as long as you don't miss anything. And then I have 24, 14, and 6. Alright, so our goal here, I'm going to write this in green. Our goal here is to get it in this form. 1, 0, 0, 0, 1, 0, 0, 0, 1, and then some x, y's, and z's. So that's our goal, just so you know what we're looking towards and what I'm doing to try to get us there. And remember, this is row 1, row 2, and row 3. So I will use that notation just so you know what I'm doing to make it hopefully a little bit easier for you as we move along. Alright, so first, so I'm going to interchange row 1 and row 3. So I'm going to have 7, negative 5, 0, 6, and row 2 stays the same. And after I once do the dashed line for the augmented matrix, I always drop it, so you don't have to continue writing it unless you want. Then 2, negative 1, 3, and 24. Then my next step will be to get this 2 here to be a 0. So what I'm going to do is take R3 minus 2/7 R1 and put that in R3. So 7, 0, 0, -5, 2, 3/7, 0, -1, 3, and then 6, 14, and then 156/7. So now what I want to do is I want to get rid of that thing right there. I want this, I'm trying to get this to be a 1, but I want that to be a 0. So third step will be to take R3 minus 3/14 R2 and then put that in R3. So 7, 0, 0, -5, 2, this will come 0. This will be 0, -1, 45/14, 6, 14, and then 135/7. So then I'm going to use that one, and I want this thing right here to be a 1. So I'm going to take it, and I'm going to multiply 14/45, which is the reciprocal of 45/14. So that'll give me a 1. Seven, -5, 0, 6, 0, 0, 2, -1, 14, 0, 1, and 6. Alright, so you could stop right there and use back substitution. Because I have z equal to 6. You could use that right there if you wanted. However, I'm going to continue doing Gauss-Jordan elimination. But it's up to you. So then you're going to use 5. There's step 5. Oh, come back. Where'd it go? We lost it. There we go. I don't know. Apparently, my hand doesn't want to cooperate today. I want this 2 to become a 1. Actually, no, I want this. Sorry, I jumped the gun over there. I want this -1 to go away. I want that to be a 0. So I'm going to take R2 and add it to R3 and put it in row 2. 7, -5, 0, 6, 0, 2, 0, 20, and then 0, 0, 1, and 6. Alright, so now I want the 2 to go away. I want that 2 to go away. So I'm going to take half of R2 and put it in R2. So 7, -5, 0, 6, 0, 1, 0, 10, and then 0, 0, 1, 6. And then now I want this little guy to become a 0. So I'm going to take R1 and add it to 5 times R2. And then I'm going to put it in R1. So I have 7, 0, 0, 56, 0, 1, 0, 10, and 0, 0, 1, 6. And then last but not least, I want that 7, this 7 to become a 1. I'm going to take 1/7 of R1 and put it in R1. So I get 1, 0, 0, 0, 1, 0, 0, 0, 1, then 8, 10, and 6. So that means that my ordered pair is 8, 10, and 6. My ordered triple here is 8, 10, and 6. where's the next one? Okay, apparently I skipped the entire page when it printed to GoodNotes, but that's okay. Alright, so this next one, I'm going to write in an augmented matrix form still. So 2, 1, -1, 2, -3, 1, -1, 1, and 0, and then 2, -28, 14, and our goal is still the same as the last time, so I'm not going to write that again, just for sake of space. So, I want to get rid of, we're going to get this thing right there to be a 0. So our first step is to take R2 minus 1/2 of R1 and put it in R2. So I'm going to have 2, 2, -1, 2, 0, -4, 3/2, and -29. And then -1, 1, 0, and 14. So then I'm going to take R3 plus 1/2 of R1 and put it in R3. So I'm going to get, because I now want this, I wanted that to be a 0. Sorry, I didn't tell you that. So I get 2, 0, 0, 2, -4, 2, -1, 3/2, -1/2, 2, -29, and 15. And then the next thing I want is for this little guy right there to be a 0. So I'm going to zoom in just so it doesn't take as much room when I'm going to take row 3 plus 1/2 of row 2. And I'm going to put that in row 3. I'm going to get 2, 0, 0, 2, -4, 0, -1, 3/2, 1/4, and then I get 2, -29, and 1/2. And then next one, so I now want this thing to be a 1. So what I'm going to do is I'm going to take 4, it helps if I go back to the pen, times R3 and put it in R3. So you get 2, 0, 0, 2, -4, 0, -1, 3/2, 1, and then 2, -29, and 2. You could stop right here and use back substitution. However, just for practice for you guys, I'm going to continue with this row reduction to get it in reduced row echelon form once again. But you could stop right here at this point and use back substitution for z equals 2. That's up to you though. So then I have this, and now I want this to be a 0. So 5 R2 minus 3/2 R3 and put that in R2. And these row things are not, these row operations are not the end all be all. You could have other things to do, other things to think about when you do this. That's up to you, but this is just how I thought about it. So 2, 0, 0, 2, -4, 0, -1, 0, 1, 2, -32, and 2. Now I want the -4 to become a, well, we'll do this one first. We'll make that a 0 first. So I'm going to add row 1 and row 3 and put it in row 1. So I'm going to have 2, 2, 0, 4, 0, -4, 0, -32, 0, 0, 1, 2, and then 7. So now I want the -4 to become a 0. So what I'm going to do is take -1/4 of R2 and put it in R2. So 2, 2, 0, 4, 0, 1, 0, 8, 0, 0, 1, 2. And then last few steps. Now I want that first 2 to become a 0. So I'm going to take R1 minus 2 times R2. And then put it in R1. So I'm going to have 2, 0, 0, 0, 1, 0, 0, 0, 1, -12, 8, and 2. And here you could solve if you wanted, but I am going to get that last 2 to become a 1. So I'm going to have 1/2 R1 and put that in R1. So I'm going to have 1, 0, 0, 0, 1, 0, 0, 0, 1, -6, 8, and 2. So my ordered triples -6, 8, and 2. And last but not least problem. I'm going to do it mostly above it just because it doesn't want to cooperate. So once again, our goal is the same, to get that 1, 0, 0, 0, 1, 0, 0, 0, 1, and then X, Y, and Z of some sort. So my augmented matrix will be 3, -1, 1, -2, 1, -1, 1, 2, -4, 15, -10, and 14. So that's my augmented matrix. So now I'm going to try and get some things to go away. I'm going to start here with this -1 to go away. I'm going to try to get that to a 0. So my first step will be to take R2 and add it to 1/3 times R1, and then I'll put it in R2. Okay, so I have 3, -2, 1, 15, and then 0, 1/3, 7/3, and -5. And then 1, -1, -4, and 14, because that doesn't change. And then now I want to get this one, that one, to be a 0. So what I'm going to do is take R³ minus 1/3 R1 and put that in R3. So once again, the top doesn't change. 3, -2, 1, 15, and then 0, 0, 1/3, 7/3, -5, and then this will become -1/3, this will become -13/3, 15/3, 13/3. Can't read my own handwriting, guys. Okay, so now I want this one to become a 0. So I'm going to take arc3 plus R2 and put it in R3. So 3, 0, 0, -2, 1/3, because that doesn't change. This will be a 0. This will be a 1. No, I lied. I jumped way too far. 7/3, 15, -5. This becomes -2, and this is a 4. Alright, so now I want this -2 to become a 1. So I'm going to take -1/2 of R3 and put it in R3. So 3, 0, 0, -2, 1/3, 0, 1, 7/3, 1, And then 15, negative 5, and 4. Oh, that should be a negative 2. I lied. Can't do basic math, guys. That should be a negative 2. Alright, so you could stop right there if you wanted and use back substitution. However, I'm going to continue just because that's what I'm doing. So this, I want that to be a 0. So I'm going to take R2 minus 7/3 times R3, and I get R2. Put that in R2. So I'll get 3, negative 2, 1, 15, 0, 1/3, 0, and then negative 1/3, and then 0, 0, 1, and negative 2. And then I want the 1/3 to become a 0. Nope, not yet, sorry. I want that one to become a 0. So I'm going to do R1 minus R3 and put it in R1. Because 1 minus 1 is 0. So 3, 0, 0. Negative 2, 1/3, 0, 0, 0, 1. And then I have 17, negative 1/3, and negative 2. And then I'm going to, now I'm going to get that 1/3 to become a 0. So I'm going to take, I'm going to get this 1/3 to become 0. 3 times R2 and put it in R2. So 3, negative 2, 0, 17 stays the same. 0, 0, nope, 0, 1, 0, negative 1. And then 0, 0, 1, negative 2. So now I want the negative 2, this negative 2 right there, that thing right there, to become a 0. So I'm going to take R1 and 2 times R2 and put it in R1. So 3, 0, 0, 1, 0, 0, 0, 1, 15, negative 1, and negative 2. And once again, you could solve it here if you wanted, but I'm just for the sake of doing the row reduction, I'm going to continue. And then I want the 3 to be a 1, so I'm going to multiply row 1 by 1/3. 1, 0, 0, 0, 1, 0, 0, 0, 1, and then 5, negative 1, negative 2. So my ordered triple is 5, negative 1, negative